This video is a tutorial on how to use the program Occular to analyze the CSV file of an asteroidal occultation. It's assumed that you have a CSV file from the program LiMovie, and we'll use that file in this analysis. So open the program. You're presented with this screen. Select the file that you're going to analyze. I'm going to use one that I've previously done from Zerbinetta. Here is the information from the CSV file as shown in Occular. First step is to select the column headings by clicking on that row right there, and we have a blue line indicating all the column headings. Next up, select the data that you want to analyze. Select the first data point by clicking it with the mouse, hold down the Shift key, and go all the way to the bottom. You can use that same technique to select any number of data points that you want to analyze. We can go back up to the top, analyze selected data. All right, we have an issue, row 894. So let's go down to row 894. Now, notice that we have a few rows here at the beginning before we get to data point 0, so we're going to have to look around 894. 894. So let's go down here. Okay, there it is right there. We have two 887s in a row. And look at the times here. Notice that this second 887 matches the time for 888. So let's get rid of that 887 that matches 888. Just highlight it by clicking that row right there and hit your delete key. It's gone. So now we have continuity. Go back up to the top, and we have to repeat the process because the program now is kind of lost as to where we are. Highlight the rows, highlight the data. Analyze selected data. Right, now it wants to know something about the time. I did not select a timestamp, so now we need to do that. So let's click yes and OK. Go back up here, double click the data point that you have the time for, which in this case is our first one. And this has been pre-done, but December 10th. So put the date in there, 7/24, and we want the center of the frame for Occular, 39.665. Enter that information in the text, and then hit that button there to place it in the program. Now we're okay. We still have some integrity issues, but let's go on and see what happens in our program. So here is the screen showing our light curve. And we still have a couple of issues with some times, but they're after the event. You can see the event right in here. They're after the event, so they should not affect the results of our recording. Let me shift this up a little bit. All right. Well, we have an integrated video, so we need to find out something about the integration. So go back over here to the very beginning and hold down the left mouse button and drag it, and you'll get a enlargement. It'll zoom in on the data, and you'll notice now we can see the integrations happening here. There's one there and there's one there. If we count them up, we get 16. 2, 4, 6, 8, 10, 12, 14, 16. So the 16, 16, here's another 16. Looks like we have a partial integration at the beginning here. 2, 4, 6, 8, 10. We got to go back, see it better. So unzoom, so right click. You'll get this window, unzoom. I'm going to go back over here and try and zoom in a little bit better here. Okay, now I can see it better. So there's our integration. So we'll go 2, 2, 4, 6, 8, 10, 12. It looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it looks like 11. So now we can right click and unzoom and get rid of this guy and restart everything. We're going to do a block average of 16 and 11. Again, highlight the column, highlight the data, and analyze. Here's our new window. Let me get this centered a little bit better. Here's our event. We're now integrating, which is what we want to do. All right, next step. Select the event bottom, min, max. This won't be very long. If it was a normal video with no integration, you can see here it's not quite 200, so we'd go 1 to 200, and that would find the event. We can change the wing size if we want to look at more of the noise before and after. 200 is usually pretty good. We need to put the magnitudes in so that Occular can be looking for a magnitude drop to verify the event. So put those in. These are from the prediction file, star magnitude, asteroid magnitude. Copy those in. Here's our magnitude drop, 1.51. We're all set. We can have the program go through and find the event. It's fairly noisy, but we do follow the Gaussian curve pretty well on the noise, so that's okay. And it found the event. If you need to, you can spread these out a little bit to see the event times. So there's our D time, 725.02.598. R time, 725.7.456. If we want to save this information, if you want to keep this, you can write this window. It'll save it as an image file. But let's go on and do the final report. It'll run through a Monte Carlo 100 times. It goes pretty quickly normally. Sometimes with more data it takes longer. And when it's done, we are presented with a number of images. Here are the D and the R times and the spread on that. Here is a histogram of the D and the R times. And finally, a display showing our times again, D and R times, signal to noise ratio, confidence level is 100%, and an indication of the error bars. Again, we can write that window if we want to save this as well. So there's our event, there's our times, there's the analysis. Good luck with your observations and your analysis with Occular.